All right, welcome back everyone for another deep dive.
Excited to be here.
Today we're looking at something that's pretty relevant these days.
Definitely.
It's speaker verification.
Yeah,
You
yeah.
know, using your voice to unlock your phone or whatever.
Right.
But, and I think we all kind of know this, it doesn't always work perfectly.
Especially
So when emotions come in,
exactly, yeah. If
yeah,
you're laughing or you're yelling or, you're upset,
right, it can throw things off.
it just doesn't,
Your voice changes.
yeah, it changes. It doesn't sound the same.
Exactly.
So the thing is,
Researchers are actually looking at this,
yeah,
and it's pretty wild what they're doing.
I know. It's like AI to the rescue, but in a way I never would thought of.
Yeah, they're using AI to kind of fight fire with fire.
Yeah. To make fake emotional speech.
That's right.
Train the systems.
Exactly.
So we're going to dive into a research paper all about this.
Looking forward to it. I think we should start with just like the basics. How does speaker verification actually work? Like I use it all the time, but I don't really know what's happening behind the scenes.
So it starts with what's called an enrollment.
Okay.
And that's where the system kind of gets to know you.
Right.
It records your voice
Gotcha.
and it analyzes it for unique characteristics. Things like your pitch, your tone, all those little things that make your voice yours.
Right. Like a voice print.
Exactly, a voice print.
I've heard of text-dependent systems where you have to say a specific phrase.
Right. Like my voice is my password.
Yeah, exactly. And then there's the ones where you can just talk naturally. Text-independent, is that right?
Yes, that's right.
So what's the difference?
So the text-dependent ones, they're relying on that specific phrase to match the voice print.
Makes sense.
Whereas the text-independent systems, they're more flexible.
Right.
They can analyze your voice no matter what you're saying.
Which is probably hard
It's definitely more challenging. And that's the area that's getting a lot of traction.
because we want our devices to understand us no matter what.
Exactly.
So, okay, how do emotions mess this up? Like, obviously my voice sounds different if I'm happy or angry, but is that really enough to throw these systems off?
It really is. And it comes down to how our voices actually work.
Oh, okay.
When we get emotional, our vocal cords actually vibrate differently.
Huh.
Even our breathing changes.
Really?
All of this affects our pitch, our tone, our rhythm.
It makes sense, but I never thought about it like that.
Yeah. And those changes can be big enough for the system to think it's a different person.
Wow. So it's not just like the AI is getting fooled by the feeling, it's like physically the sound is different.
That's exactly it.
That's crazy. So does that mean that people who are just naturally more expressive, would they have more trouble with these systems?
It's a real concern.
Yeah.
And it highlights the potential for bias.
Uh-huh.
We need to be thinking about these things as we rely more and more on voice interfaces.
Absolutely, yeah.
Especially for things like banking or accessing our homes.
Right. High stakes stuff.
Exactly. So addressing these issues is super important.
So that's where this AI stuff comes in, right?
That's right.
Using AI to, what was it? Create synthetic emotional speech.
Yes.
That just sounds counterintuitive to me, you know? Like, if the problem is emotion, why would we add more of it?
It seems like it, but the logic is this.
Okay.
If we can train these systems on a ton of different emotional variations,
Yeah.
then they'll be better at recognizing the speaker no matter what.
Ah, I see. So it's like giving it more examples to learn from.
Exactly.
But the synthetic speech still has to sound like the same person, right?
That's the key. It can't just be a generic angry voice.
Yeah.
It has to have the individual's unique characteristics.
Right. Otherwise, it defeats the whole purpose.
Exactly.
So how do they do that?
So researchers have been working with this AI framework called CycleGAN.
Okay, CycleGAN. I think I've heard of that, but refresh my memory. How does it work?
So imagine two neural networks. One focuses on the spectrum of the voice.
Like the overall quality of the sound.
Exactly. And the other focuses on the prosody.
Prosody.
Yeah, it's like the rhythm and intonation of the speech.
Okay, so like how the words are delivered.
Exactly.
That makes sense. You need both to really capture how emotions change our voices.
Right.
But how do you guarantee that the synthetic speech still sounds like the original speaker?
So CycleGAN has these two clever mechanisms built in.
Okay.
One is called cycle consistency.
Cycle consistency.
And basically, it ensures that if you take a neutral voice and you convert it to, say, an angry voice,
Yeah.
and then you convert it back to neutral, you should end up with something very close to the original.
Oh, so it's like a way of checking that the AI hasn't just created a generic angry voice.
That's exactly it.
Smart. And then what was the other one?
The other one is called identity loss.
Okay.
And that focuses on preserving the unique traits of the speaker's voice.
So it's like a double check to make sure the AI isn't losing the individual in the emotion?
Exactly.
Wow, that's pretty impressive. So in this research, they focused on angry and happy emotions, right?
They did, and there's a reason for that.
I was going to ask why those two.
Well, those emotions tend to be high energy and very different from neutral speech.
So they're like good test cases, really push the limits of the system.
That's the idea.
Fascinating. So the big question is, did it actually work?
That's what we're here to find out.
I'm dying to know, did this whole synthetic emotion thing really make a difference in how well the systems could recognize speakers?
Let's dive into those results after a quick break.
Oh, come on.
Got to keep you on the edge of your seat.
All right, fine. But we're coming back to this right after the break, folks. Don't go anywhere.
We'll be right back.
Stay tuned. I used to spill the beans. Did this whole synthetic emotion experiment actually work?
It did really well, actually. The first thing was they found that CycleGAN could actually convert neutral speech to angry and happy while still sounding like the same person.
Really? So, like, if I heard it, I would still know it was you talking.
Yeah, exactly. They actually tested this with real people in listening tests.
Oh, wow. That's cool.
And they also use a technique called TSNE to visualize speaker embeddings.
TSNE.
Yeah, it's kind of like creating a map where each point represents a voice.
Oh, okay. So you can see how the voices cluster together.
Right, and they found that the synthetically generated emotions clustered near the real ones.
So they were believable, essentially.
Yeah,
But, I mean, the real question is, did it actually help the speaker verification system work better?
right, and that's where it gets really exciting. They trained speaker verification systems using this augmented data with all those synthetic emotions, and they found that the systems were significantly better at recognizing speakers even when they were expressing those emotions.
So, like, less likely to get fooled by a change in tone?
Exactly.
Yeah.
They even saw error rate reductions of up to 30% in some cases.
30%, that's huge. So it really does seem like giving the system more examples of emotional speech, even if it's synthetic, helped it learn how to handle those variations.
That's right. It's like it learned to anticipate how those emotions could change a person's voice and got better at matching them to the right speaker.
That's really remarkable. But were there any downsides? Like, did using this synthetic data mess anything else up?
You know, that's an interesting point. There was actually a slight dip in performance on neutral speech.
Huh. So, like, it overcompensated.
Kind of, yeah. It's like it became so focused on detecting emotional cues that it sometimes started seeing them even when they weren't really there.
Interesting. So it's a bit of a trade-off then.
Yeah, it highlights the complexity of the problem and that even with these advancements, there are still things to consider.
It's like anything, there's always going to be unexpected consequences.
Absolutely.
But overall, it sounds like the benefits outweigh the drawbacks in this case. Did they uncover any other interesting insights?
Oh, yeah, for sure. One key takeaway was that it wasn't simply having more data that made the difference.
Okay, what do you mean?
It was the synthetic data itself. It seemed to contain unique signals that were really valuable for the speaker verification system.
So it wasn't just about quantity, it was the specific type of data that mattered.
Exactly. That's a big insight, and I think it has implications beyond just speaker verification.
Yeah, it makes you wonder about the potential of synthetic data in other fields.
Absolutely.
So anything else?
Yeah, they found something really encouraging, actually. They found that using the synthetic data helped close the performance gap between neutral and emotional utterances.
Oh, that's really important, right? Because we want these systems to work equally well for everyone, no matter how they're feeling.
Exactly. It makes the system more fair and consistent.
That's great. So it sounds like this whole CycleGAN approach has a lot of potential. What are the broader implications of this research?
Well, this study focused on just two emotions. But imagine what we could do if we could generate synthetic data for a whole range of emotional states.
Wow, yeah. Or even different acoustic environments.
Exactly. Like, think about being able to reliably verify your identity, whether you're using a high-quality microphone or just your phone.
Or if you're in a quiet room versus a crowded street.
That's right. It's all about making these systems more robust and adaptable.
And if we can create synthetic data for all these different situations, wouldn't that save a lot of time and resources?
It definitely could. Plus, think about the potential applications beyond security and authentication.
Oh, yeah, like what?
What if we could have AI that truly understands and responds to human emotions?
Wow. Yeah. Like, imagine a smart home that can sense your mood and adjust the lighting or music to match.
Exactly. Or a customer service bot that can detect frustration in your voice and offer more personalized support.
It sounds like science fiction.
It does, but this research shows that it might not be that far off.
That's incredible. It's really blurring the lines between science fiction and reality.
And speaking of blurring lines, all of this brings up some big questions.
Like what?
Well, if AI can mimic human emotions this well, does that mean it's actually understanding them?
Ooh, that's a good one.
Or is it just a very sophisticated form of imitation?
That's a question that philosophers have been debating for centuries.
And it's only getting more relevant with the rise of AI.
Let's unpack that after a quick break. So, is it understanding or is it imitating? I mean, that's a pretty deep question, right?
It really is, and there's no easy answer.
I mean, obviously, AI doesn't experience emotions the same way we do, right?
No, definitely not. They don't have the same biological and neurological makeup as humans.
Right, they don't have the same kind of lived experiences and memories that shape our emotions.
Exactly. But the fact that they can generate such realistic emotional cues in speech is pretty remarkable.
It's true, it really does make you wonder.
It suggests that there are underlying patterns and structures to human emotion that can be modeled, even if the AI isn't subjectively feeling those emotions.
So we're kind of teaching AI to be emotionally intelligent, even if it doesn't actually feel
That's
emotions.
a fascinating paradox.
It is. It's like AI is forcing us to look in the mirror and really examine what it means to be human.
Exactly. By trying to teach AI about emotions, we might end up learning more about ourselves.
I like that, a two-way street of discovery.
Yeah, and who knows, maybe studying how AI generates emotional speech will give us new insights into how our own brains process emotions.
Wow, that's mind-blowing. This whole deep dive has been incredible. We've talked about the nuts and bolts of speaker verification, the potential of synthetic data, and even the philosophical questions around AI and emotion.
It's been a really interesting journey.
It really has, and it just goes to show that even seemingly technical topics can lead to some really profound questions.
Absolutely.
Well, thank you so much for sharing your expertise with us today. This has been a truly fascinating conversation.
It's been my pleasure.
And to all our listeners, thanks for joining us on this deep dive. If you're interested in learning more, there's a whole world of research out there on speaker verification and emotional AI.
It's a rapidly evolving field with new discoveries all the time.
That's right. So stay curious, everyone, and we'll see you on the next deep dive.